Hi everyone. Today we're going to be learning about 7.2, which is systems of three linear equations. Back in Algebra 2, you guys learned systems of linear equations, but it had to do with only two systems. Today we're just going to add a third one in, but it's very, very similar to what you guys have done back in Algebra 2. So to get started, a system of three linear equations can be written out similar to capital AX plus capital BY plus capital CZ, and that will equal a constant that we will call capital D. All right. Just to be clear, the letters A, B, C, and D are all numbers. They're all coefficients, or in D's case, that is just a constant all by itself with no variable. All right. One thing to make note of when we're talking about systems of three linear equations is that all of these three, A, B, and C, cannot all equal 0. Okay? It is allowed that one of them can be 0. It's allowed for two of them to be 0. But if all three of them were 0 at the exact same time, that would eliminate all of my x, y, and z's. So I wouldn't have any variables to work with. So that is why that is the case. All right. And of course, the letters x, y, and z are our variables. Okay. Now that we're introducing the letter z, again, back in Algebra 2, the letter z introduced a 3D model as opposed to a 2D model with x's and y's. So when we write our final answer as a coordinate, before we introduced the z, the coordinate was always x comma y, and now that we're introducing a z, it's going to fall at the end. So we should have an answer with three parts, x, y, and z, in that order. So we're going to go through how the process goes, and we're going to be using elimination here throughout more often than not. Every once in a while we might be able to use substitution, but more than likely we have to use elimination. So first we want to rewrite as a linear system in two variables. I'll show you what that means. I'll show you what all of these steps mean here when we get some examples. Then we're going to solve the new linear system for both of its variables. And the central idea is to take two different pairs of equations and eliminate the same variable from both parts. From both pairs. That is probably the key. If I were to put this in simplest terms, the idea is to eliminate the same variable in two separate equations so that we can continue with elimination that we learned back in algebra and that we learned back again in Algebra 2. All right. Then once we know any of the values, whether it's x, y, or z, we can substitute them back in and find into the original equations to solve for the remaining. And of course, as always, the reason why math is so awesome is because we can always check our solutions. Okay. So before we get started, just a quick refresher on elimination. Elimination is much like the word itself. You are eliminating something. And what that something is a variable. Eliminate a variable. And the way to do so is by manipulating or changing the function or equation. Manipulating is like multiplying everything by 2 in order to make things cancel, things like that. That is what manipulating is. You're not officially changing the equation. You're just doubling the equation, tripling, whatever you need to introduce. You're doing it to all parts of the same equation. Then we have substitution. And again, if you relate substitution to like a game of basketball, okay, you are substituting in for another player. You don't just go onto the court and all of a sudden have 6 players on there, okay? You are swapping out with a specific person. Same thing in math. We are substituting a value, or function, depending on what we have to work with, for a specific variable. So if I were to send you into a game of basketball and say, hey, you're going in for Johnny, you are specifically going in for Johnny and nobody else. So that is who you are substituting in for. Same rules apply here. So let's get started on example 1. Give myself plenty of room here. We are going to take up quite a bit of space. So back in Algebra 2, what you guys have seen is you saw only 2 equations. All right? But now we're adding that third one in so that we're going just one step further. But in reality, it's really truly the same idea. All right? So what I'm going to do is step 1, I'm going to choose the first 2 equations. Now this is just the way I do it. If you prefer something else, by all means, if it works and you understand it a little bit more your way, do your way. That is totally fine. But what I'm going to do is I'm going to take these first 2 functions that are listed. This is step 1. I'm going to rewrite them, and I'm going to show all of my work for you guys just so you can follow along. If you start to see the pattern here and you don't need to show all your work and you can kind of do that mental math, that's fine. That's on you. But when it comes to the test, if we can't follow your work and you get something wrong, we can't reward you points where points are deserved. So keep that in mind. All right. So all I've done so far is just taken the first 2 equations as is, haven't changed them a bit. All right. Now looking at those 2 equations, I'm going to just choose a variable that I want to eliminate. And more often than not, I like to choose x just because it's the first thing that shows up. So if I look at my x coefficients in both equations, I have a 4 and a 2. But if I were to say, well, now I want to eliminate x, I need to make that bottom equation into a -4 in order to eliminate that. And in order to do that, I have to manipulate the equation, there's the word manipulate, by introducing a -2. Now, the only way this is going to work is if I do it to every single term. I have to distribute that -2 to every single term. So, before I get to that, again, this is just how I do it. If you can see the mental math and do it in process, that's fine. But I'm going to rewrite it. I'm going to have the first function with no changes whatsoever. And then my new function I'm going to put here in red with that -2 distributed to everything, including that -14 at the end. So that gives me -4x plus 6y minus 15z, or excuse me, not 15, minus 10, sorry, I looked at a 3 there, minus 10z equal to positive 28. And now, as I work down, I get to officially eliminate the x term, and I'm left with 8y minus 7z equals 29. So now I have a system of only 2 variables, which is good. And now what I have to do is I'm going to take the next 2 equations. That's my step 2. So essentially, I'm using the middle equation twice. Again, you can use any 2 as long as you just don't do the same 2 both times, because that's going to get us nowhere. All right. I'm going to choose the last 2. So again, writing those down. Followed by 6x minus y plus 4z equals -1. In order to make this whole process work, I have to eliminate the exact same variable. So if I eliminated x back in step 1, I also need to eliminate x in step 2 as well. So looking at my x terms, I have a 2 and a 6. Well, I know that together I can make, I should use red here, together I can make a -6 by multiplying or manipulating this equation by -3. And so I'm going to rewrite everything with its changes. So I have a -6x plus 9y minus 15z, and it is going to equal, need my calculator here just to be sure, 42, positive. Bring everything else down, got a 6x minus y plus 4z equals negative 1. Okay. Now, if you were to look at my teacher notes as I'm kind of looking over them here, it looks like I chose the first and second one to start with. And then when I did my second equation, I only chose the first and the third. You're allowed to do that also. Okay, there's nothing wrong with that. I just, depending on what I'm looking at, what I'm feeling, I just take the first two, the last two. You are going to repeat one of them no matter what. That's not an option. But definitely don't repeat both of them. Okay, so my x's are going to cross out, leaving me with an 8y minus 11z, and now it's going to equal 41. All right, that is the only change, the only new thing that you guys haven't seen. Okay, now all we have to do is continue the elimination process, but this time my new equations are these two right here. So I'm going to write them down. This is step 3. As is, 8y minus 7z equals 29. Oops, don't need that line there. And then the other one is 8y minus 11z equals 41. Again, still working on elimination, so I'm going to work to eliminate any variable. I'm going to choose the y's just because looking at the y's in my equations now, they're both 8s. So it's a quick and simple fix to introduce a negative to all of my terms, manipulating everything by a negative. And again, I don't have to rewrite everything. If you see what's happening here, we can just work it out. So for example, what I mean by that is if I'm going to introduce a negative to everything, let's just flip all the signs. That way I don't have to keep writing everything down over and over again. So that's going to give me a negative 8y, a positive 11z, and a negative 41. Now when I add them down, my 8y's cancel. I'm left with a 4z, and negative 41 and 29 gives me a negative 12. And so if I continue solving just for z and dividing by 4, I know that my z answer is going to be negative 3. So just to get my answer started here, again, I should have 3 parts, x, y, and z. So I know that z is negative 3. I can fill that in. Now the only other 2 things I need is my x and my y, and this is where substitution comes in. So if I know z has to be a negative 3, I can choose to take that negative 3 and plug it into this function. And I'm choosing this, either one of these, honestly, because there's only 2 variables. I wouldn't choose necessarily any of the systems to begin with because they all have 3 variables. And the only thing I know right this second is one of them. So I want to stick to the least amount of variables as possible so that I can continue. So I'm going to work with this equation over here. Again, that's just a preference. This will be step 4. And this is substitution. So what that means is I'm substituting in a negative 3 because now I know that z has to be negative 3. No matter what, in those 3 functions, z has to be a negative 3. So now it just becomes a solving game for y. Subtract 33 to both sides. And what do you know? You get a positive 8. So that must mean that my y value now is going to be a positive 1. Go back to my final answer. In the y position, I can put a 1. And last, but certainly not least, now that I know my z is negative 3, my y is 1, I can plug it into any one of my 3 equations because now the only thing I'm missing is my x. So I'm just going to choose the first one, mostly because I want to steer clear of that negative 14. That does not look very pretty to me. And that will be step 5. We're going to use substitution again, but this time, every time I see a y, I'm going to plug in a positive 1. And every time I see a z, I'm going to plug in a negative 3. Again, I'm using that first equation from this problem, the original equation. 4x plus 2y plus 3z equals 1. And now we continue to solve. I got 4x plus 2 plus 9 equals 1. Moving everything over to the other side that doesn't belong is going to give me 4x equals, was that negative 10? Negative 10. All right, let's see here. Ah, that's what I missed here. When I plugged in my z, I forgot the negative 3. I just put in a positive, so that's going to make this a minus 9. Which brings me to tell you guys that when you do your homework tonight, you should get all good values. You shouldn't get fractions. The reason I knew that that was kind of a red flag there was I was going to have to divide a 10 by 4, and that was going to give me a fraction. So just for a rule, okay, it's not going to always be the case, but for your homework for sure, and I'll double check for your test as well, we will steer clear of any sort of fractions. All right. So I know that x is 2, and last but not least, I will finalize my answer as 2, 1, negative 3. Again, representing x, y, and z. Okay. And again, that last step on that front page there told you that we can always check. The way you can check is by going back to any one of the original 3 equations and plugging in each one of your x, y, and z values. And if you plug all of them in at the same time with their respective places, you should either get a positive 1 if you're at the top equation, a negative 14 if you're in the middle, or a negative 1. So you can always take that extra few seconds to double check your answers. All right. So what I'm going to do is I'm going to skip question 2. All right. You have the teacher notes posted and available to check your work, but I want you guys to practice this one. So we're going to skip 2 and we're going to go to question 3. Okay. Again, notice that all of these questions have x, y, and z all on the same side, followed by all of the constants on the other side. So that is the form we are looking for, just to help with the elimination process. That's really the only reason why. All right, so keep that in mind. So, now that I'm looking at question 3, again, let's try the same approach as we did in the first example. I'm going to take the first 2 equations, write them down, and I got 4x plus 4y plus 4z, and that's equal to 7. Again, depending on whichever variable you prefer to eliminate, we can do that. So let's say I want to eliminate x again. That would mean that I would have to manipulate the top equation and multiply it by a negative 4. So that's going to give me a negative 4x minus 4y minus 4z equals negative 12. And if I copy down the same second function, now I can try the elimination process. And what happens here, as soon as you start the elimination process, your x eliminates just like we wanted, but then also our y eliminates and our z eliminates. So the number that's still on that left-hand side, now that everything is gone, is still a 0. Okay? And then when I have a negative 12 and I add that with a positive 7, that gives me a negative 5. So what happened here is that all my variables canceled, which is fine, it is possible, but now that I'm left with a 0 equals negative 5, I stop for a second, I'm like, whoa, what happened to all my variables? They went missing, okay? Again, that is fine, but what I want you to focus on is this last statement. I'm left with 0 equals negative 5, and that is absolutely, positively not correct. All right, so the fact that that is incorrect and not possible tells me that there is no solution. because it's never going to happen. All right, so if you ever come out with a false statement, that is what we will call this here, as a false statement. We know that 0 in fact does not equal -5, so we end up with no solution. Okay. And then there's question 4. Looking at question 4, we have x plus y plus z is 4, x plus y minus z is 4, and then 3x plus y plus z is 12. All right, so again, let's try that whole elimination process one more time. Let's do the first two. Step 1, we got x plus y plus z equals 4, followed by x plus y minus z equals also 4. All right. I know that in the previous examples, I eliminated x right away. You can totally do the same thing. All right. The only reason I'm choosing not to this time is because if I look at all my variables, right now, based off of these two equations, my z's get to cancel as is. I don't have to manipulate anything, fix anything, or any of that. So I'm going to cancel those, leaving me with a 2x plus 2y now equal to 8. All right. Then I'm going to go ahead and do the next two functions, trying to eliminate the same variable z, which is nice because, again, if you look at what's happening here, z is ready to eliminate as is. I don't have to manipulate a single thing. That's going to give me a 4x plus 4y equal to, did I lose negative? No, 16. Okay. Now in step 3, remember we have to bring them together, the two equations that we have here with x and y. 4x plus 4y equals 16. And again, let's choose x to eliminate. Why not? If I choose to eliminate an x, that means I have to introduce a -2 to the top equation, leaving me with -4x minus 4y equals -16. And the original second equation, this is all the positives, seeing what's happening here. And now if I go to eliminate everything, this cancels, so I have a 0 on the left-hand side. And when I have a -16 and a +16, they also cancel each other, so I have a 0 on the right-hand side. So yet again, my variables canceled, which I said is okay, but now I'm left with the 0 equals 0. And that, in fact, is a possible solution. That is allowed because it is a true statement. So what we're going to say is that this is a true statement. And whenever it is true, that means that no matter what values you choose for x, y, or z, it is always going to work out. So you can think of any numbers in the you can possibly think of, and they will always, always work. And because of that, that tells us that we have infinitely many solutions. So many solutions, in fact, that we just don't know how many, so we're going to say infinitely to cover all our bases. And that is only because we had a true statement. So if it comes out to say 5 equals 5, 6 equals 6, -10 equals -10, those are all true statements, so they will work out. All right. So again, if you haven't yet, make sure you try question 2 on your own. Looking through my teacher notes, I'm very, very detailed on them. So if you have questions, please let me know. And then your homework will be posted momentarily. Again, on your homework, make sure that you have no fractions for your answers. You will be good. All whole numbers, positives or negatives, are allowed. All right.